Losing trees, gaining carbon dioxide. We have seen that carbon dioxide is necessary for the greenery, but excessive carbon dioxide into the atmosphere is bad for the global warming. So why is this carbon dioxide being excess in the atmosphere? We are going to talk about it. Deforestation is another cause for the increase in the atmospheric carbon dioxide. Not only usage of the fossil fuels which emit the carbon dioxide, but also the inhalers of carbon dioxide that are trees are cut down. So the carbon dioxide is emitted into the atmosphere, but there is no other entity which would be absorbing that carbon dioxide other than the trees. And why we are removing all the trees, by the name of the industrialization, or maybe making it more luxurious. So the removal of large areas of vegetation due to the industrialization is one of the culprit of increase of the carbon dioxide into the atmosphere. The removal of carbon dioxide for the atmosphere is diminished since the trees are gone. The carbon dioxide emission is increasing because we keep on dumping the carbon dioxide into the atmosphere, but there is no way of removing it from the atmosphere. So that is why the problem is. What is a fossil fuel? The term fossil fuel is used to describe those materials that have been formed over millions of years by the decay of plants and animals. Coal is formed when the stems from the decay of large populations of swamp plants over the period of millions of years that will get hardened and become coal. Oil and natural gas, this is formed by the stems from the decay of the marine organisms such as algae and plankton. So when these things take millions of years to become hard and become fossil fuels. So there are many fossil fuels, and out of them, the methane gives the most energy when you burn 1 kilogram of it, and then gasoline, then coal. So some of them are more efficient than the other, and the hydrogen is a non-fossil fuel which gives out more energy than any other fuel. So burning the fossil fuel releases its stored chemical energy. So as you can see from this chart that some of them are more efficient than others. You can see the carbon monoxide gives you the lowest amount of energy, and the other type of the fossil fuel is methane, which gives the most amount of energy. You can see this hydrogen right here, which does not fall in the fossil fuel category, but it gives most energy per gram burned. So oil and gas, automobile and other vehicles are the primary consumers of oil and gas, and US is the single importer of the crude oil, single biggest importer of the crude oil, and it imports about 6.9 billion barrels. This is according to 2007 data, so now it would have been about doubled. So you can see these blue dots that shows you where these are abundant. So these are the regions where the chief oil and gas deposits are there. Importance of fuel efficiency. So each gram of gasoline burned in an automobile requires 15 grams of ordinary atmospheric air in order to burn. So by making the more improved engines, then it could not only save the energy but also reduce the toxins into the atmosphere. And importance of fuel efficiency, improvements in the design, which is engineering a better vehicle, sometimes like making a hybrid power, like whenever there is not huge amount of energy is needed, the battery could be used to operate it, and then whenever you need excess energy, then the fuel should be used. So if you have a hybrid power like that, then the emission of the carbon dioxide would be a little bit less compared to the sole fuel-based engines. The cleaner fuel, so cleaner means not we are talking about the dust, but the way it produces the carbon dioxide into the atmosphere. So when you look at all the other fossil fuels, methane gas is more cleaner because it produces less toxins when compared to the other gases when you burn them. Coal, the coal is the cheapest fossil fuel, and we have it abundant. So when we have a very abundant, then what is the problem? Is that carbon dioxide emission. So when you burn coal, it gives the most carbon dioxide into the atmosphere. Coal produces nearly 1/3 of the carbon dioxide than oil fuel. Coal is responsible for 40% of the 30 billion tons of the carbon dioxide released into the atmosphere by human activity. It's a very inefficient, only 2 to 4 joules of every 10 joules of heat can be converted into useful energy. So that is the reason, even though we have coal very abundant, we do not use it or we do not prefer to use it, and we try to go for alternate sources just because it is not very efficient. Making the best of coal use. There are several methods used to try to reduce the carbon dioxide impact of coal burning. The first one is carbon capture and storage. So like, whenever the carbon dioxide is emitted, instead of leaving it to the atmosphere, just store it and capture it and store it, which is called the sequestration. And the other way is gasification. So instead of leaving the carbon dioxide when it is emitted when you burn the coal, instead of leaving it into the atmosphere, so make the carbon dioxide react with some other chemical and make it as some other gas, and then either capture it or release into the atmosphere. Or so that is another way. So coal is transformed into a mixture of gases, and carbon dioxide is easier to capture. So syngas can be made from the methane production, used in methane production. So the syngas, a little bit cleaner version of coal, can be used in methane production, which is cleaner gas. Still coal is problematic because acquisition is dangerous and the pollution is very serious. Severe respiratory effects on those who live nearby the coal burning plants. So whenever they dig these coal mines, there could be a possibility of all these radioactive elements released into the atmosphere, such as uranium, thorium, radium, and mercury. U.S. Environmental Protection Agency has led efforts in trying to reduce harmful coal burning emissions. So all these agencies try to protect humans, and they try to reduce the coal acquisition or try to find a way to decrease the toxification of the atmosphere. So what are the alternatives? So alternative sources should be a better sources, such as alternative sources should be less toxic and should be more abundantly available. So alternative energy sources that are used right now are giving about 15% of the energy required by the commercial use. And these alternative energy sources should be cleaner and safer. So even though the alternative sources are very safer and cleaner, we are not using it because of the cost. So we are still reluctant to use these alternative energy sources because of the cost. Fossil fuels are still very inexpensive. Nuclear fuels, a better way. Nuclear reactor is based on the fission. So when we say fission, this is nothing but the breaking apart or decomposition of large nuclei. So whenever you take a nuclei and if you break it into pieces, that's called fission. When you do that, then a huge amount of energy is produced. Fission was first used in the production of electric power in 1951, Idaho. So nuclear power plants produce enough energy to save 20 million barrels of oil every day. So you can look at this bar chart right here. It tells you that all these European countries are way ahead of United States in using these nuclear reactors. You can see that about 78% of the energy is coming from these nuclear reactors in France. So about 50% in Belgium. So this figure shows the percentage of electric energy produced by the nuclear power plants by each country. These plants produce about 450 gigawatts of electric energy. Advantages with the drawback, that is nuclear power plants do not emit carbon dioxide, so it is very safe for environment. The major drawback is the safety issue. So in the past, in the three locations, the very huge accidents happened, such as 3 Mile Island, Chernobyl, and Fukushima. So this failure generated significant anxiety in the public sector. Even though it is an excellent energy source, just that when there is an accident happens, then hundreds of thousands of people could die, and also the radioactive elements could get into the atmosphere, and it could bring a lot of health issues to people. In one of the examples is the tragedy of Chernobyl in Ukraine. In 1986 in April, 1 gigawatt reactor was destroyed in an accident, and the reactor failure resulted in the escape of nearly 200 tons of radioactive material, and the radioactivity in the fallout was about 400 times harsher than it was produced by the Hiroshima atomic bomb. Everybody is aware of the Second World War, and the atomic bomb was used in the Hiroshima, Nagasaki in Japan, and we hear the stories that still there is no sign of trees growing or plants growing in that location. So you can imagine how bad it could be if it is 400 times harsher than that when there is a failure in the nuclear reactor. So thousands of people became ill. So you can see like an apocalyptic type of skin diseases to people, and respiratory skin diseases and things like that happened after this. So it's a huge thing, and that's the concern people have in especially United States. Ideal energy sources. The ideal energy source should not deplete the resources or harm the environment. So in US, about 5% of the total electricity comes from such sources which would not harm any of the environment or which would not deplete any of the natural resources. Two broad categories. One of them is continuous. So we are talking about the energy sources. Some of them are continuous sources that you will have the source working all the time, such as hydroelectric, geothermal. So these things will be there forever. Variable energy sources, the rate of energy production varies with the time of the day. For example, solar. So you know that half of the time is day, half of the time is night. So half the time you have sun, half the time you don't have sun. So that's why we say it variable, because in summers you have huge amount of sun, and winters you have less amount of sun. So these are the things which put them in the variable resources. And the others vary with the weather conditions, such as wind and waves. Sometimes we have more, sometimes we have less, etc.